So in this question, it is given that vector A, vector B and vector C are three vectors such that magnitude of vector A is 3, magnitude of vector B is 4, magnitude of vector C is 5, and each one of them being perpendicular to the sum of the other two. Find magnitude of vector A plus vector B plus vector C. This is what we have to find. So let us now observe what is given and how it is going to be helpful in finding the solution of this question. Something that they have declared right in the beginning. They have given the magnitudes of A, B and C as 3, 4, 5 respectively. So this is an information that we'll be utilizing at a later stage. What else? Each one of them being perpendicular to the sum of other two. Each one of them, suppose out of A, B and C, if I talk about say A, it is one of them. So each one of them being perpendicular to the sum of the other two. So A is perpendicular to the sum of B and C. Likewise, if I take into consideration vector B, it is perpendicular to sum of other two. Other two means vector C plus vector A. And likewise, if I take C into consideration, C is perpendicular to the sum of other two. That means it's sum of vector A and vector B. So this information is with us. Find magnitude of vector A plus vector B plus vector C. Now, one of the most important things you should remember while dealing with magnitude of a vector. Whenever they're asking you to find magnitude of some vector, taking square of the magnitude is the initiating or the starting step. It is very, very helpful. Why? Reason being, if I take magnitude of x whole square, square of magnitude of a vector is same as the dot product of vector with itself. Sometimes it's written as vector x whole square also. So it will become easier to convert from magnitude to the dot product by using this formula. So it is advisable that you start with the square of the magnitude, and at a later stage when you simplify and when we wish to write the final expression for the magnitude, you can take positive square root towards the end of the question. So let us keep that in mind and start with, since here also they're asking for the magnitude of vector A plus vector B plus vector C. So let's start with magnitude of vector A plus vector B plus vector C whole square. This is what we have. We need to start with. Now keeping this in mind, so this can be written as dot product of this vector with itself. That means I can write vector A plus vector B plus vector C. It's dot product with itself. This means vector A plus vector B plus vector C, like this. Now we will open it in a way that we have to do least calculation work, right? Now if I open it this way, vector A, it's dot product with A. So I'll write vector A dot vector A. I'll write vector A dot vector A here. Likewise, I'll be taking vector B dot vector B in addition, vector B dot vector B. Likewise, vector C dot vector C. remaining combinations like A with B is left, A with C is left. Now we'll take into consideration what they have given is vector A is perpendicular to vector B plus vector C. So this information I'll be writing vector A dot. I have utilized A with A till now. I haven't utilized A with B and C. So I'll keep B plus C intact and it's done its dot product with A. So I'll be writing A dot remaining two vectors, vector B plus vector C plus. Likewise, I have utilized this B with B only, vector B with vector B only. So vector B with A is left, vector B with C is also left. So I'll be writing it in a manner vector B dot vector A plus vector C. Something related to it is given here also. Plus, till now I have used vector C with vector C here. So with C, A is left, with C, B is also left. So I'll be writing vector C with the sum of vector A and vector B. No need to expand throughout, means the way I don't need to write A dot B plus A dot C, B dot A plus B dot C. Can open it in a systematic manner so that you have to do least calculation work. Now observe it using the same formula. If it is dot product of A with itself, so it is magnitude of A whole square using the reverse of this formula. So I can write it is magnitude of vector A whole square. Likewise, for vector B dot vector B, I'll be writing magnitude of vector B whole square. For C dot C, I'll be writing magnitude of vector C whole square plus A dot B plus C. Now, in the question, it is given that vector A is perpendicular to vector B plus vector C. If this is so, dot product of A with vector B plus vector C is equal to 0. That means vector A dot vector B plus vector C, this term will vanish. This is 0. Likewise, B is perpendicular to vector C plus vector A. So B dot vector C plus vector A is also 0. And towards the end, vector C dot vector A plus vector C is, or vector B is also 0. So this term is also 0. So these three terms, they will vanish. So we'll be left with mod of vector A square, mod of vector B square, mod of vector C square. And rest all terms will vanish. So no need to write. Now the next information, they have given us the magnitude. We haven't utilized it anyway. Magnitude of vector A is 3. So 3 square, that makes it 9. Magnitude of vector B is 4. 4 square makes it 16. Magnitude of vector C is 5. 5 square makes it 25. 16 and 9, 25. Another 25 makes it 50. Here. What are we being asked for? We're being asked to find magnitude of vector A plus vector B plus vector C. Remember, we started with square of vector A plus vector B plus vector C. So I'll be writing magnitude of vector A plus vector B plus vector C whole square. Its square comes out as 50. Since we are dealing with magnitude, so just need to take the positive square root of this term. So towards the end, I can write vector A plus vector B plus vector C is a positive square root of 50. 50 is 25 multiplied by 2. So I can write 5 root 2 as a magnitude of vector A plus vector B plus vector C. So this is again a very, very good question from Cbse point of view. So over to question number 8.